M1 Kinematics Example 15. At the top it says Example 15 is a tricky one. So this is going to take a little bit of problem solving. So try and pause the video and just read the question and see if you can develop a bit of a strategy for how you might go about solving this question. If we read the question, it says a ball's falling vertically from rest from the top of a tower 63 meters high. Okay. So the whole tower is 63 meters. Now, A is falling from the top. The fact it falls from rest is given to us in the question. So for particle A, we know that u is 0. It's going downwards, so the acceleration due to gravity will be positive. It says at the same time that A begins to fall, another ball B is projected vertically upwards from the bottom with a speed of 21. So for B, now, got to be really careful here. For this one, I'm taking downwards as positive. For this one, I'm taking upwards as positive. So we've just got to be a little bit careful with what we're doing. So for this one here, for B, upwards is positive. So U is 21. So that means A will be minus 9.8. Just make sure that you're consistent. A is going down, B is going up. Okay. It tells us that these two balls collide when they've gone a certain distance and they've been travelling for a certain time. Now we know that the time will be the same for both balls because they collide, so because they started at the same time, they must have been travelling for the same amount of time, but we don't know what that time actually is. We're asked to find the distance of the point where the balls collide from the bottom of the tower. So let's say they collide round about that point. So A will have come down from the top, B will have come up from the bottom, and there will be a point where they collide. Now, we need to come up with something to represent these. We don't know what these distances are. I'll call them distance 1 for ball A, and I'll call it distance 2 for ball B. Now, I don't know a tremendous amount about S1 and S2, apart from the fact that I do know that S1 and S2 together must be 63. So, for example, if the ball had fallen 40 metres from the top, the other ball must have come 23 metres from the bottom in order for them to collide. The tower is 63 metres high. So let's see what we can do with this. Well, for the first ball, using S equals ut plus a half a t squared. S1, the distance that that ball has gone up, ut, well, u is 0, so this will be 0. And then we're going to add a half times a times t squared. So simplifying that, we know that S1 is 4.9 t squared, but that's about as far as we can go. We don't know S and we don't know t. If we did the same thing for this second particle, same equation, S2, the distance travelled there, will be ut, so it's 21t, plus a half a t squared. So S2 is 21t minus 4.9 t squared. And again, that's probably about as far as we can go really with the algebra on that one. Now we do know that the two displacements, S1 and S2, add together to give 63. So if I do this algebraically, S1 is 4.9 t squared, S2 is 21t minus 4.9 t squared, and together they equal 63. Now I've noticed I've got a positive 4.9 t squared and a negative 4.9 t squared. That's because they were going in opposite directions. And so actually they'll cancel out, and all we'll be left with on the left-hand side is 21t. So 21t equals 63, cunningly chosen so it works out to be a whole number, I think, on this question. So t is 3. So in other words, this point here where the two balls collide is after 3 seconds. That's really helpful because now we can work out both distances. Now let's read which distance we really want to work out. Find the distance of the point where the balls collide from the bottom of the tower. Well, from the bottom is S2, so I'll work out S2. You could work out S1 and take it away from 63. Either will do. So I'm going to sub t equals 3, the time it takes for them to collide, into this second displacement, S2. So we're going to have 21 times 3 minus 4.9 times 3 squared. Substituting that in, it works out to be 18.9 meters, and we should really round that to 2SF, so that would be 19 meters.